All right, this is lesson continuing 5.7, part B. We're still completing the square, and it's page 22 in your notes. The two things we're going to look at today is how do you complete the square when you have a coefficient in front that is not equal to 1, so right here where we have the 2. And then the second thing we're going to look at is how we can use completing the square not only to solve, but also to convert from standard form back to vertex form, which is something we talked about. So go ahead and draw a squiggle line here because we're going to use both sides for two different problems. Our first problem here, completing the square, we need to actually take care of this 2 in a special way. So we factor him all the way out in front, and then we still have our 6 on the side here. But we need to have that 2 come out of this piece. And I know this is tricky, but here's what it's going to look like. Pull out a 2, you'll have x squared plus 1/2 x, and then we still need that blank space for what we're going to add. Now, when we take that 1/2, remember it's half of b, and then squaring it, that's what gives us the c value here. So half of b means 1/2 of half, and then squaring it. So if we take half of a half, using our calculators or our memory of fractions, that's a quarter. And then we need to square that. So we end up getting 1/16 over here. Or if you're dealing with your calculator and you got a decimal, you would have 0.0625. Now, before we add that to the other side, remember that this 2 is multiplying times everything in these parentheses. So we're not just putting 0.0625 over here. In this space, we need to put 2 times 0.0625, or 2 times 1/16. So we end up getting 0.125 over here, 0.125. Now, when we come down, we're still going to keep the 2 here. And again, what would this have given us if we FOIL these parentheses? This would give us x plus, this is a half or a 0.5, but we found quarter. So we're going to say 0.25, x plus 0.25 equals 6.125. So we have 2 parentheses, x plus 0.25 quantity squared equals 6.125. Before we can square root, we now need to divide by 2. So we end up getting x plus 0.25 squared equals, and then if we divide this by 2, we get 3.0625. We bring in our square roots, and again, we have a plus minus in front of that square root. So we end up getting, cancel this, x plus 0.25 equals plus or minus the square root of that number is 1.75. Go ahead and subtract that negative 0.25 over to both sides. We have x equals negative 0.25 plus or minus 1.75. We are running out of room. All right, but remember there's 2 answers for your x. Negative 0.25 plus 1.75 will give us 1.5 for x, and negative 0.25 minus 1.75 will give us negative 2 for x. So these are our 2 answers. So really the work is a lot of the same, except for this whole factoring 2 in the front, and we ended up having to divide later on by the 2. And then also when we had to multiply that end value by 2 at the back. Those were the only differences. All the rest is the same. We still did the 1/2 b squared. We still factored into 2 equal binomials, and then we took square roots all the way down. Let's try another example like this. We're going to go ahead and we're going to try. All right, so here's another one we're going to try, same idea. We want to set it up so that there's a blank spot at the end. So first thing we need to do is we need to move that 8 out of the way. We don't need him over here. So we end up getting 3x squared plus 30x equals 8. And then we want to factor out the 3. super important. So we factor out the 3, we get x squared plus 10x plus, and then this is where we put in the what do I need. We're going to make sure we add it to both sides, blank. We're taking half of this value, so 10 divided by 2, and then squaring it, so we get 5 squared. So we need to put a 25 in here. And then instead of adding 25 to this side, remember there is a 3 times everything. So 3 times 25 is 75 over here. So our next line is 3 parentheses x plus 5 times x plus 5 equals 75 plus 8 is 83. We have x plus 5 quantity squared. 3 times that equals 83. Divide both sides by 3. And 83 divided by 3 is x plus 5 quantity squared. This is not a nice decimal. It does not end, so we're going to leave it as a fraction. Square root both sides. Put the little plus minus. Cancel, cancel. So we end up getting x plus 5 equals plus or minus square root of 83 thirds minus the 5 from both sides. So we get x equals negative 5 plus or minus the square root of 83 thirds. Now, depending on what the directions say, how far they want you to take it, remember this is one type of answer. It can also be split into negative 5 plus the square root of 83 thirds, or it can be negative 5 minus the square root of 83 thirds, either way. So that's how you deal with completing the square. Again, when you have that leading coefficient that is different than 1. Okay, you just have to kind of factor him out, do a little bit more work. The second way we're going to use completing the square today is we want to put something in vertex form from standard form. So again, remember here's standard form, sum ax squared plus a bx plus a c. But vertex form is when you have y equals a times x minus h quantity squared plus k. And what we want to do is we want to go ahead and get this piece here the same way we've been finding a perfect number at the end that we can slip in. So in order to do this, first of all, we set it equal to 0 just for a second. We'll put a y back in at the end, but it's easier for us, because we're going to have to move some pieces around, to call that a 0. The first thing is that we need to get this 2 out of the way. So we're going to move the 2 over. We get negative 2 equals x squared plus 6x plus, and now we can put in the blanks here. What would make this perfect? Well, half of 6 squared. So 3 squared, which is 9. Now, good news, we don't have to multiply anything here, right? There's no parentheses, so we just add a 9 to both sides. And that gives us 7 equals x squared plus 6x plus 9. Go ahead and factor this. This becomes x plus 3 quantity squared equals 7. We're almost there. Do you see how this looks like that perfect piece that we have? Now we're going to go ahead and move the 7 back. So we will have 0 equals x plus 3 quantity squared minus 7. And then we're now ready to go ahead and put the y back in. So all along we just kind of had a 0 for a moment, but let's put him back, and we get y equals x plus 3 quantity squared minus 7. There is vertex form for what was something originally in standard form. And remember, vertex form means that you can read the vertex super easily. We can pull out negative 3 comma negative 7 as our vertex. We don't have to do any angry sheep business. Let's do another example like this, converting. So convert it to vertex form. So start by setting it equal to 0 for just a minute. It gives us some extra room to play with. Go ahead and move that last piece over and out of the way. So x squared minus 10x plus blank. And then we'll add whatever is on the right has to go on the left. Go ahead and take half of your middle term and square it. So we get negative 5 squared, which is positive 25 to both sides. Then we get 23 equals x squared minus 10x plus 25. And we end up getting x minus 5 quantity squared. This is the important step. So many people move the 23 back over, but then guess what? You're back up to the original gray. We don't want that. Please make sure that you factor this right away so that you don't put the 23 back in. And then we'll move the 23 back to the other side. So we get 0 equals x minus 5 quantity squared minus 23. And now we're ready to put the y in. Y equals x minus 5 quantity squared minus 23. Vertex form of the exact same parabola that we see in standard form up above. So congratulations. That's another way to use completing the square.